Welcome to another video on my Arduino Uno, which is the smallest normal Arduino board. You can't do very much with it, and the things I've done with it are already in the series of videos with Arduino Mega 2560. The most important features are pulse modulation and I2C, and both of them I already have gone in depth with. So why this video? Well, kind of wrap up. First of all, in the mentioned video series on the Arduino Mega 2560, the motor that I controlled with the Arduino Uno gave up, didn't work anymore. As you can see now, this motor works, although not in the way that I envision. I have changed some of the wiring. That is one of the most important aspects of this video. I am using these connectors now. There are 3 of them, black, which is ground, intended for ground, then 2 plus ones, VA and VB, because there are 2 separate compartments. However, I have interwired them, so I use only this one. All connected right here. Then pot meter connected to input here to regulate the speed of this motor. Then output through the yellow wire to this LED, then another one through this LED, and then some wires for the motor. And that can be about it. Could be about it. I rewired them to make sure that wires are not easily disconnected, because that is something as a main theme almost through my videos. Wires tend to get disconnected by using breadboards, unfortunately. But with this observation, there are some more things that I want to share, and for that it's better if you see the software, the oscilloscope and the board in one piece, so, or in one screen. So let's go to the screencast and see how everything comes together, I hope. Alright, so now what's going on? First of all, look at the oscilloscope. This is the pot meter. This one is the pulse modulation. Pulse modulation at the entrance of the transistor circuit. And there you see things. This is the digital signal the signal from the switch, and then I mean, of course, this switch right here, and this one is right now not connected. So what is the big deal? Well, actually, what I do not like, and I should actually use another pin right here to make clear what I am talking about. Is this one. Now let me try to fix that, and of course doing it alive. unprepared. Yep, that's it. Now I'm using the force probe to show what I exactly mean. Which is that for some reason now this wire, let me make it better light, this wire which goes to the motor to provide the pulse modulation is only working from here, while it should be working from there. So now it quits, and now it should work as well. And the crazy thing is, if you look at this signal, what do you see? Right, it gets its signal from the other way. So the question is, why is this happening? Also, something that is not quite alright is this one. Because this LED should be burning as as a sign that the transistor circuit is actually working. It doesn't. So I'm removing this one and put this one in. Now I've just checked and this one is working. And now I have to put it in correctly. Yes. And now I'm seriously wondering why this one has stopped working now. It did it for a moment and it quit. So why does it quit? If I use it right here, and now is the question what's going on, it still works. You see, although it's a faint glimmering, it does work. So now I have to turn it around. For some reason now everything has with the motor has stopped working. That's not the intention, but okay, time for pliers to straighten everything. Alright. Right. So now this is working. Now I know that the transistor circuit is working actually. However, and now look at both of them. So now I should be getting the same signal from here, which is not the case obviously because the motor isn't running. Okay, put back here, it works. And I once again hear the motor whine. It does want to work. And given the pulse of signal here, it should. But here it does work. So that is something curious. Can I change this by changing the setting of the pot meter? Let's just try. Right, so now with this screwdriver, and mind you, the voltage has just gone up, so that is not entirely what I envisioned either. Oh dear, I need a different screwdriver. You will always see that something else happens. Let's see if I can try this one. Yeah, okay. Ooh, that's very fast. And this is very fast. This is maximum, but also these two values are maximum. And then the motor does nothing. Oh, it does. Just a bad connection once again with the potmeter. So now the question is, if I move this wire, what will happen? Absolutely nothing. Nothing happens at all. And here it keeps working. On, well, it's not exactly the same signal, but close enough. Oh, and you see that the LED gives a very different brightness at some moments. Right now it's even off. Now it's on. So let me just put it here and wait. It's off now. And it's fully on. And why that happens, I don't know either. Or I should watch the output from the monitor. But it isn't showing any difference. So, and here it immediately starts working. So there is still a difference. And needless to say, when I put it here, it skips the whole transistor circuit altogether. Which reminds me, I might change the transistor. I might swap it. For one that I do, that one that I know it works. So let's just do that. I take this one out right now and see, that is why I name it, I call it skipping it, because it just keeps working. And now I put in another one, this one. Okay. And now I put it right here. And now it works. So it is a matter of transistor after all. And that was also the case with another now ended video series on the Arduino Mega 2560. One transistor works, another doesn't, and they are both the same model. no, the same type, different model. They are both NPN, but they are different models, as I already indicated. And as of why this LED goes off and on, I'm not sure. It's not a connection anyway, otherwise it wouldn't do it at all. But I'm very happy that it works. And let's see if if it stays working with a different setting of this. Alright, now it's halfway, as you can see here. Signal still going. Pulse modulation still going on both ends. So at the base and at the collector. Is it the collector? Yeah. Let's see if this is the collector. Taking the schematics. So this is the emitter and the motor is behind the collector. So that's correct. Base, emitter, collector. And the motor is connected to the collector, as is the diode. So now this schematics is actually brought to practice with this wire connected in the correct way, of which I'm quite happy now. This one is now halfway. This one is connected nicely. So this one A0 gets the analog value, and this one gets just the digital version of the same signal. And that may be very clear. Let's stop the auto scroll. So digital input, and this is the A0, which is not logical. Why would that be 0? Why would sensor value A0 be 0? That doesn't make sense. It's coming from the switch. There's some voltage over it. And every now and then it has some voltage. Okay, let's see the code again. What is sensor value? I am assuming that sensor value is coming from A0. Yeah. So it is the switch sensor value. And going back to the monitor. And here sensor value is being hit and has a nice value right here. So that does work. Very nice indeed. So now everything has come together for the Arduino Uno. Wrap up. Changing setting of the spot meter, but most importantly changing replacing this LED, and even more important, replacing the transistor. Then rewiring, and that makes all the difference. Well, the transistor does. So with this as oscilloscope image, which you also saw on the screencast, some tools to rewire. This one to the breadboard connections, to make sure that these connections, the pluses, are not messed up anymore, and everything works nicely. Can you do more? Well, you could do more, but everything has been explored by now. For much more, I would say watch my series on the Arduino Mega 2560 in combination with the Uno for serial peripheral interface as well as I2C, because you need another board, another device to make use of it. In itself, nothing happens. But now I fixed everything and it works. Thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment or suggestion. You can also follow me on Twitter and Instagram. And feel free to make a donation to support my blog. And you can donate via PayPal or Wired, and you can also become a patron and have your name mentioned as a supporter. Your name will be mentioned on my website anyway, but depending on your pledge, also with my videos. More information, or all information, is right down under this video, including the URL of my website, which much more about my projects, well, all about my projects, etc, etc. Once again, thank you for watching, and bye bye.